All right. I'm going to start partly because, this is the last session before lunch, so I just want to get it done. Thanks to everyone for coming. Hopefully some evaluation forms will show up so you can give me a piece of your mind at the end of this. My name is David Thomas. I'm the Director of Academic Tech here at CU Online. And for those of you that have come to some of the symposiums in the past, you might remember Brian Youngke used to do an annual thing called Top 10 Technologies to Watch, until one year he told me he didn't want to do 10 technologies. And so I said, name it something else. And he said, what? And I said, well, whatever you want. He said he couldn't think of something. So I said, then fine, we're going to call it the Blast-Off Report. So we made him do the Blast-Off Report for a couple of years, and then I think someone else did it last year. And this is what's come of it. So this year, in sticking with our theme, we decided to call it something else. So for the context, everyone knows this, right? It's the Lakeside Amusement Park, home of the Cyclone. It's a replica of an old roller coaster used to be at Coney Island. So this is the Ride the Cyclone session, and really it's a replacement of the Blast-Off Report. But I'm going to talk very high level about a couple of acronyms, or three acronyms that you might find interesting. AI, BI, and VR. I think we all know what these stand for. Artificial intelligence, business intelligence, and virtual reality. I have some kind of conventional definitions I want to use here for you because I don't really want this to be a technical talk. But really, AI has started to come to represent the field of machines doing kind of brain work, and that fits into a lot of areas. And so I don't really want to get into the deeper philosophy of whether or not machines can think or not. But clearly, we've got machines that are doing what really amounts to brain work. BI, it's a terrible name, business intelligence, but really it's an easy way of talking about data and what we do with it. And I'll talk more about this, but there's so much data now, it's become a really interesting field with a lot of relevance to higher ed. And then finally, virtual reality, again, it's kind of a broad church, but I like to think of it as terms of it's just this thing that we're using, these technologies that are helping us really feel present in digital space. And for those of you that don't know, part of my area of academic study is in architecture, so this idea of presence in space is really important. It's kind of inherent to who we are, and VR is touching on that. And if you haven't done the VR demo upstairs, make sure you do it. It's super cool if you haven't seen contemporary VR technology. So let's dig into it. Let's start with AI. When I say the word AI, what do you think of? What's that? Robots? Yeah. There it is, yeah. You think of HAL 9000. Why? Because it represents the peril and the promise, right? I mean, HAL's intelligent, but HAL's like crazy and dangerous and kills or tries to kill all the astronauts, right? But HAL's kind of still with us, surprisingly enough. And I think it's really important that we stop thinking about AI as being in the future, because AI is with you right now. It's your Siri, it's your Alexa, and it's your Google Now. Whether you like to think about these things as AI or not, absolutely the science of AI is driving those technologies. We have the shortest technology memory span in forever. Like 10 years ago, we said people will never have Dick Tracy-like watches. Yeah, now we have phones that do that, 5 years ago, even we're saying, well, we've got rudimentary, recognition of speech, but it's the holy grail. There's no way computers will ever understand common speech. And what if we put understand in quotes, well, sure they understand them. We talk to our machines all the time. And with probably about the quality of the response of a 4-year-old, they do what we ask them to do, right? So it's immature, but it's still there. So we know AI is a thing and it exists. And it seems that it's going to get better. And there's different schools of thought around it, but I kind of tend to lie on the school of thought that says machines don't have to be intelligent in order to act intelligently. And as we apply more and more computation power and even data to them, they start to do things that look like thinking, even though philosophically we might be a little disgruntled to call that intelligence. There's one of these kind of tech watcher pundit guys named Shelley Palmer, and he's a bit of a he's a self-promoter, I guess, but he's a pretty smart guy. And I was reading one of his articles, and I love this quote right here. And I want you to read this quote and think about your world and your world as a teacher. And he says, to change your world, AI does not need to replace humans, right? We're gonna outsource all jobs to robots. It just needs to displace you. So stop saying AI can replace humans and start asking, can AI displace me? And to me, that's a really interesting question, because I think most of us would say, well, AI can't replace me, but AI could replace a lot of the things that we do. And we start to see, like with self-driving cars, I mean, you'd say like, well, a robot could never drive me to work. Well, yeah, it kind of can, and it's probably going to soon. A robot could never grade my papers. A robot could never respond to student emails. A robot, the list goes on and on and on. And we see that getting chipped away at. And here's a really interesting example that he uses in the article. I want to break it down for you. This is this thing on Amazon's net job impact, right? So Amazon employs all these people, like there's 145,000 people. It's a giant company. That's a lot of employment gain. The problem is it made those employment gains by putting almost 300,000 people out of work. So the net job loss is huge. So you start to say, you don't say, oh, is Amazon and all of its efficiencies and logistics and ordering and inventory management going to put people out of jobs? The answer is like, is it going to put me out of a job? So I think that the Amazon model is super interesting to look at in terms of like our world in higher ed, and start to think, how does higher ed look different in a world where lots of things that are done by people now may get done by machines? And I'm trying to encourage a new, less cataclysmic look at how machine intelligence is changing our world. Instead of like, will robots teach our classes? It's rather, what happens when an individual professor can effectively teach 50, 100, 500, 1,000 students? What if that leverage point gets to the point where we start to see the economics of higher ed change? Maybe not naturally what we do, but how we do it. And so in that sense, I love this painting. This guy does these amazing paintings of the future. You should look up his website. But I love this picture. It's this police car, you see. This little kid's controlling this mech, His little buddy's watching him. It's this sort of like deeply kind of ironic and hilarious. But I think that's the metaphor of the future, right? It's not, are we going to be different? It's going to be, how are we going to be different when we have this incredible power at our hands? What are the professors that get it and have this power, being used? How is that going to look? How's that going to change? How's our world going to be different when the professors with the technology really come into their own? And here's some evaluation forms for you to fill out. So, but let me give you an example from my world, because to me, this is sort of this interesting kind of parable built of real parts about what's actually happening right now. Last year, we came across a little company called Acree. And Acree is a very, very simple piece of software. It only really does one thing. It does automatic assessment of writing. Okay? That's their claim. Their claim is that in a blind review, you can have their software grade 100 papers, and you can have a professor, a TA grade 100 papers, and the difference will be within like 2 points on a 100-point scale, right? It's crazy, right? They make this claim. And so we're very interested in this, so we want to take a look at Acree. Now, I should just kind of jump to the end of that story. In practice, we brought some faculty together. It didn't look like it was ready for prime time. So it's not rolling out here anytime soon, so don't worry. But we just brought it in. We're trying to look at this. We're trying to always test the temperature. Is it hot enough yet? And I don't think Acree is hot enough. But here's where the story to me gets really interesting. Who is Acree's ultimate enemy, right? Like if this is a superhero battle, who is Acree's arch rival? Well, it's this guy, Les Perelman. Les Perelman was a composition professor at MIT, and this is actually I ripped from the headlines, the man who killed the SAT essay. This guy in his lab was more or less credited with single-handedly ending automated essay grading in the SAT. And the way he did it was by looking at how this all worked. He basically demonstrated it wasn't assessing the right stuff. It was easy to trick. I mean, there were certain things like length of essay mattered more than anything else. And so, really, a high-powered, really smart guy with a very precise criticism ending the SAT. And so Acree is this company that's kind of like still in that water. And so they feel that they're rising to Les Perelman's level of critique, but maybe not, right? And we have faculty here that say they don't think that they've achieved that. That's cool. not the end of the story. If you go look at Les Perelman's Vita, which I did, because I talked to the Cree people, so they told me this, so it's not that conspiratorial. Look at his last other positions currently held. Chief Research Scientist, Wright Lab. Oh, so he's working with a startup. That's cool. I think that's a really awesome thing. Anybody care to guess what Wright Lab does? Automated essay. Feedback. Doesn't do grading. Does feedback, right? That's cool. So now we come full circle. Guess who one of Acree's competitors is? I don't know what to make of this other than it delights the hell out of me because it shows you how messy this is. There's not good guys and bad guys. There's not like a point of view that the enlightened techno-utopians get and the Luddites over here don't understand. It's really messy, and it will continue to be messy. And that's exciting to me because it tells me that there's a lot of fertile field for us and that we should stay open-minded and critical at the same time. So I like the idea that, like from my department's view, that we can continue to bring in crazy provocative technologies and that faculty can shoot them down. So I think that's the kind of dialogue that we need to have. But that's AI. AI is this thing where machines are being asked to do human brain work. So let's talk about BI, because what could be more exciting to follow up artificial intelligence than business intelligence? So we're all familiar with business intelligence, because if business intelligence is our data and how we use it, then really it's all about like getting data into a format that we can use to help inform decision making. So in that kind of broad definition, we all use business intelligence. We all look at our grade books and decide, make decisions about things. We all, try to collect feedback like these little forms and try to do something with it. We're constantly using our data to ask questions. So in that sense, I don't want you to see BI as something that somebody else does. I want you to start thinking about BI as something that we all do. And I don't know, maybe my friends in the School of Business could give me a better term, but I just use BI because people generally know what that means. But we all do BI. So what? Where does this get interesting? Well, it gets interesting because if you only have to manage 10 pairs of shoes, that's not a problem. And if you become one of those crazy people that have 1,000 pairs of shoes, you have a shoe storage problem. You have a shoe finding problem. And our data has gotten so big so fast that it literally is mind-boggling. I'm going to boggle your mind. So we're going to play a little game, okay? So does anybody remember the kilobyte? We still have them. What is 1,000 kilobytes? A megabyte. Remember megabytes? Remember my first Macintosh computer. I bought a hard drive for it. It was a 20 megabyte hard drive, and I think it cost $500, and I was the coolest guy in town. How many is 1,000 megabytes? A gigabyte. Okay, gigabytes. That's kind of, now we're getting somewhere, right? Gigabytes. We all got gigabytes on our phone. You can buy a 16 gigabyte card for, I don't know, $7 or $8 now, right? What's 1,000 gigabytes? Terabyte. See, you guys are good. Okay, a terabyte. Now we're starting to get into some serious kind of cloud storage, like big data stuff, right? What comes after terabyte? Petabyte, yeah. We don't talk much about petabytes now just because we're still filling up our terabytes. But when you start to get at scale, there are companies that are generating databases that are at the petabyte scale, right? I think our friends in the personalized medicine field are probably getting close to some of those data sets. What's 1,000 petabytes? Partly I'm running you through this to just to make you realize that in your lifetime, in the last 10 or 15 years, you've been learning these new words because we keep reaching these new orders of magnitude. It's an exabyte. So you probably have no idea what 1,000 exabytes are, and you might even ask, why the hell do we name these things? Zettabyte. I'm going to talk more about a zettabyte in a second, but what is it? Millions, billions, trillions, quadrillions. This is a sextillion. That's how big of a number it is. And by the way, just because it's going to happen eventually, what's 1,000 zettabytes? Of course, it is a yottabyte. Okay, so. And these are all Greek terms for these large numbers. Okay, So let's focus for a minute on zettabytes, right? Zettabytes are actually a part of our world, and here's why. This is from an article I read. Our connected digital world is producing data at an accelerated pace. There were 4.4 zettabytes of data in 2013, like, available. That's projected to grow to 44 zettabytes by 2020. So, and it says IBM estimates that 90% of the data in existence today was produced in the last 2 years. That's crazy. We're going to actually get to the yottabyte in the foreseeable future. So when we talk about business intelligence being our data and how we use it, oh my gosh, we have so much more data than we ever had before. It's crazy to start to think about. So what's happening? Well, this is the good old, our friend, the hockey stick diagram. This is what, these exponent diagrams look like, right? These power curves. Oh, wait a minute. I'm sorry. That's global warming. Here we go. There's hard drive capacity by year. It's doing the hockey stick. Here's Moore's law, right? That's computation power. Number of transistors. Does this look familiar? And some of this is cheating. I mean, I know you can draw these diagrams at different scales to get different effects. Just for fun, here's world population. And, oh yeah, here's the number of guests at Airbnb on New Year's. We're living in a very weird world because things aren't moving linearly. They're moving exponentially. That's why we have to count storage in orders of magnitude, because it just keeps getting big that fast. So what does this mean in the world of data? Well, it might mean nothing if we had all the time and all the money in the world. And here's why. Anyone know what that is? That, my friends, is a Turing machine, the universal computer. Alan Turing, one of the fathers of computer science, actually proved that with enough time and enough memory, this is a piece of tape that just goes back and forth. So if you had an infinite length of tape and an infinite amount of time, that machine could compute anything computable. So that little thing right there could calculate anything if you had infinite time and infinite storage, which means infinite money. What are the two things that we don't have? Time and money. So as this data gets gigantic, it starts to raise the question of what are we going to do? Are we going to drown in our data? So I'm going to start to bring this a little bit closer to home to like our world, right? If you're a research scientist and you have a formed data set, this is very exciting, right? Because it's just like you're getting mountains of data to mine. If you're an administrator in higher ed, it's perplexing, like what to do with all this data. If you're me and you're in the business of trying to rationalize all this, this is what the world of data looks like. Lots and lots of data means lots and lots of vendors. And I started to make this chart and then I found it. This is this guy's clip. Every single one is a logo of a company in the data space, in the BI space. So you got guys like down here, you got your Hadoops and your kind of your open source storage stuff. I mean, here's some of your infrastructure providers. You may see some logos of people that you know. And this is just daunting. I mean, it really is daunting. And so what's happening is groups that are actually care about this are trying to simplify this. So at IT, for CU Denver and Anschutz, we're trying to simplify this. We're trying to take that giant mess of tools and get it down to something that starts to look manageable. So now I'm just going to talk a little bit briefly about what we're doing here. So here's two logos for you to look at, and two logos that might be of interest to you. First, I'll talk about Tableau. Anyone here use Tableau? Cool. What do you use Tableau for? Student tracking? Okay. There you go. So Tableau is, if you've ever made a pie chart in Excel, Tableau is just like that. It's like way better. It's a platform for doing data visualization. It's really fast. It's really easy to use. And so this is from the Wikipedia, interactive data visualizations product focused on business intelligence. So you take Tableau and you point at a data set, and then you can turn lots and lots of tabular data into something kind of human usable, right? So how do you get that data into a format, this overwhelming mountain of data? One of the solutions we're looking at, we haven't done any deals with them, but I'm just going to give you as an example of these guys, Exasol. And you're kind of like, is this the part where I go to sleep because you're starting to just like an IT geek on me? Close, but not quite. What is Exasol? An in-memory, column-oriented relational database management system. Why do you care? You don't. What you care about is Exasol is this next wave of technology that's so smart through AI and so fast because of computational, reasons that it takes lots and lots and lots of data and makes billions and billions of rows of data look like you're searching your address book in your old, Access contact database. That's cool because now all of a sudden you don't have to be a data science expert to get lots of data out in a format that's usable to really quickly. Tableau is a great way to visualize it, but if you're a researcher, perhaps you use SPSS or maybe you use some other tool. This Exasol, again, presents everything just like you want to see it in a really nice, fast format. So the good news is around BI. The bad news is getting bigger fast. The good news is the tools are getting really freakishly cool. So what does this look like in practice? This is a pilot project that we put together at CU Online, which we lovingly called the Dean's Dashboard. And it's just a pilot project, but it was a way for us to easily visualize enrollment data and to kind of compare enrollment trends for online. And what you're seeing here is actually data that we generated in Tableau. And so I just wanted to sort of show you really quickly, like this is the next world you're going to start to hear a lot about is the world of dashboards. And really what a dashboard is instead of being delivered static paper with charts and graphs or Excel files with lots of data, it's very hard to go through. You're going to start to see more and more of this. You're going to start to get parameterized visual reports. And I hid the parameters, but you can go through. You can select your school and college. You can drill down on a specific subject. And as these things get more and more rich, it basically has the effect of pushing consumption of large scale of data down. So it's, in a way, it's a joke. It's the dean's dashboard, but the deans aren't the target. That's just the start, right? We need to get data cleaned up for administration, but we need to move it down into department chairs, move it down into individual faculty. People need to have data to make decisions. I don't believe in data-based decision-making, but I do believe in data-informed decision-making. What I mean is we should stop arguing about facts. Like, I don't know how many conversations I've had with people that say, I think online is a fad. And I'm like, define a fad, because it's been going up for like 20 years. Here's the facts. We can argue about what the facts mean, but can we please not argue about the facts, I don't know how many times I had people say, I don't believe online is outpacing face-to-face. I'm like, well, your belief is not a part of the equation. Here are the facts. And so by creating sources of data and ways for people to consume the data, I think that we have better conversations. We can talk about what it means and what we should do about it. Then there's dark data. Anybody know what dark data is? I'll give you a hint. It's not data that Batman the Dark Knight uses, although it would be cool. And it would be really cool if computers actually look like that. This is dark data. This is the haunting side of data. From a TechCrunch article, between 70 and 80% of data that is unstructured, or percent of data that's available is unstructured. It's dark, therefore largely unusable when it comes to processing and analytics. My research friends in here know all about this. It's all that stuff that's missing columns, it's missing rows, it's missing labels. It's log data that you just don't know what to do with. And if you Google dark data, the most common picture that you're given is of an iceberg, because the idea is most of what the iceberg is under the water. Although I looked this up. Here's a good one for you. How much by percent of a saltwater iceberg is underwater? I guess there really aren't freshwater icebergs, but that's right. More. 90. It's a science equation, right? It's a buoyancy equation. So 90% of an iceberg is underwater. So if you ever see a drawing of an iceberg, it should be 90% underwater. So I think that's interesting. What does this mean? I'm talking about zettabytes of data, and everyone's familiar with this. It's kind of like I don't know if you've ever been in a meeting, any kind of academic planning meeting, and people are arguing about enrollment figures. And you think, we don't know how many students are in our program, or we don't know how many credits they're generating. And the answer is no, we kind of know in general. I mean, people will ask me, how many online students do we have, David? And I say, well, what do you mean by an online student? It turns out that there's a lot of data that doesn't point to information. It's just sitting out there. And so you can kind of feel like desperation. Well, there's just so much unstructured data. We'll never get it right. People enter bad data. We don't have a way to clean it out. Except, wait, remember that giant diagram of vendors? First, let me talk about what dark data is. Here, let me give you some examples so to bring it more to home to you. So here's some examples of dark data I pulled from somebody else's definition. That's not dark data. That's just awesome. Okay. Call notes and meeting minutes, presentations, research and report, email conversations, customer and account information, because they student information, service tickets and customer complaints, knowledge-based articles. We all generate this stuff. I think there's a great Deming quote that says, along the lines, if an organization actually could harness the things that it knows, they could change the world. Same thing. We just have a lot of data sitting around that we just don't know what to do with. And then it's simply any kind of document. So we're surrounded by dark data. And again, dark data is not bad guy data. Dark data is just data in a format that's unstructured that we can't seem to apply the tools and techniques of BI to. Or can we? I'll get to that. But let me show you an example of the benefit. This is out of order, so I apologize. What do you do when you have lots and lots of data? This is an example of this. In Canvas, we have about 1.5 billion rows of log data, every single click, every single student, every single course. And that's just a lot of data. It's not dark data. It's just data that we got to look at. And this chart's messed up. But we can do things like look at activity utilization, which is great if you're an IT person. You're trying to figure out like when people are online or not. And you filter it by school and colleges. The profiles are different. Like for whatever reason, this is the general profile. People tend to be not on it early in the morning. But if you're dentistry, it's like apparently do testing or something because it's like from 11 to 1 on Tuesdays and Thursdays is really busy. That's when Canvas is really busy. But this is mined out of like just mind-boggling amounts of rows. In the past, 1.5 billion rows was so big you need a supercomputer to crunch it. Using tools like Exasol, we can make 1.5 billion rows of log data. Again, look like an Excel spreadsheet. It moves so fast. So it's exciting what you can do with big data. So now let me return to dark data. I'm dying to talk about dark data. Dark data is going to start getting lit up. And if you look this up, Deep Dive is a software out of Stanford. And basically what it does is it uses machine intelligence to go out and figure out how to structure unstructured data. In other words, it figures out how to, machine-wise, figure out how to light up data. So all of a sudden, you can start pointing it at things like email or pointing it at piles of notes and stuff, and it will allow you to start using the tools of BI, those performance gains of things like Exasol, the visualization tools like Tableau, to find things about it. And if you think this is really way, way, way early, you're wrong. Apple just bought the company that the commercial side of Deep Dive called Lattice. They just bought it for $200 million. The company's about 5 years old. This is the next stage. We're going to start seeing machines are turning data that we thought wasn't data into data that can be consumed. All right, so real quick, VR. I don't have a lot to say about VR because, hey, you can go upstairs and see it. We're going to have a whole cool keynote about it. But I did want to talk briefly about it. Does anybody know who this guy is? Mark Zuckerberg. Mark says this is early and it's going to be long-term thing, speaking of VR. It's a good candidate to be the next major computing platform. It's worthy of a lot of investment over a long period. Facebook bought what company in the VR space? You guys know? Oculus. They spent a couple $2 billion on it. Facebook bought a VR company. So if you go upstairs and see that the goggles that we're using is a different company, same thing. They bought a platform company. What does he mean by platform? He means in the future, the metaverse, virtual reality, that people are going to be engaging each other in these virtual worlds. They're sold on this. They're so completely convinced. Now, Mark Zuckerberg may just be a nerd, and he's just excited about this. But I want to tell you that stop thinking about VR as just entertainment. Stop thinking about VR as something that's just sci-fi, because there is serious momentum around this. And when you listen to John's keynote today, be thinking, what changes in higher ed if VR starts to become real? Because I'll tell you what, this is what we do today, but if I'm a kid sitting in a class looking at this, and I can just click the switch, I'm going to be gone. Because there are much better places to be than in your stinky old classroom. And we got to be there. And I don't know what that looks like, and I don't know when it's going to happen, but I don't see any particular barrier that's going to keep us from getting there. So let me wrap this up real quick. If you start thinking about these in kind of these matrices, if you think about AI as decision-making, BI as data, and IR as presence, or VR as presence, right? Then you start to think about how are these markets going to move and how are they going to grow? I'm interested in what kinds of things happen at their intersecting points. So right now we already see As AI starts to mature, we get self-driving cars. And it definitely has something to do with BI because they need good maps and they need good data, but it's mostly AI. It's mostly about the speed of computation in those vehicles makes it possible for them to drive safer than you. What happens when you have great amounts of data tied to AI? Well, you get personalized medicine, right? You start to, the AI is important, but the data is more important. I need to know a lot about you. And once I know a lot about you, it turns out you're like a lot of other people, and I can start to diagnose things. And we already see this with Watson personalized medicine and stuff. It's very interesting. It's very interesting to think that robots could be very good at diagnostic medicine. When you start to have a lot of data and you have really great presence, I think you get simulated places, right? Right now, the thing that keeps things from being complete in VR is it just takes a lot of data to make all the blades of grass and all the trees and all the bugs and all the fishes. But as we get more and more and more data dedicated to those places, virtual worlds are going to be incredibly rich and vivid. They won't just be like visual places. They will be vivid simulated places. When you really start to swing around and start to combine AI, less data, more AI, you start to get really crazy video games. If you think kids are hooked on video games now, wait until the games are really extensive and really immersive and really challenging because of the AI brings essentially robot opponents fully to bear. And I think there's another area that we should not mistake is virtual companions. I mean, usually it seems to be coming from the darkest quarters of the human, kind of id, virtual companions. But you're going to see this. You're going to start to see legitimate relationships form between human beings and their virtual companions. And it may be as much as, like your virtual aunt who just sends you sweet messages and asks how you're doing. But you're going to be able to have real conversations with these things that feel very meaningful to you. Okay, that's just the world, right? What about us? Let's look at us real quick. Let's look at, like what does this triangle look like in our world? What kinds of things should we be kind of keeping our eyes out for? Well, I already mentioned essay grading and coaching. It already exists. It's just going to get better as the AI improves, right? When we get more data to bear, we're going to have amazing personalized curriculum. Come on, guys. If we can do personalized medicine, surely we can figure out personalized curriculum, right? And it's just a matter of finally getting the data into a format that we can look at it and start to make meaningful decisions with computers about what's the next thing that person needs to learn to reach mastery. Down here, simulated locations. I'm not kidding you. This is done. This is a wonderful, holdover from the Middle Ages. And once we finally have meaningful simulated places, I think that we're going to start spending more time there. And why would you want me to give you a history lecture in a classroom if I could take you to a historical location in a simulation? Why would you want me to lecture about, a medical procedure when I can just show it to you, right? And I love this, like the dentists, they're like all on board with video because mouths are really small and it's hard to get a lot of people looking into a mouth. And so I think Mike's done some of this, haven't you, like with dissection? Let's bring cameras closer to the problem. But if it's like really vivid and it's simulated, why set time in a classroom? Why not just let me show you and you can get as close to it as you need to do to understand what's going on? This is going to happen. It's happening now. Likewise, simulated labs and environments, we already see some of this, but as we have really good AI connected to VR, then we are allowed to create very rich experiments. So it's not just like they are now, kind of branching things. We can have, here's a whole bunch of chemicals, mix them together, see what happens. The robot will actually figure out the science and blow you up if it needs to. And then finally here, I'm not going to go so far as virtual professors. I think professors are going to float on top of this, but we are going to have virtual TAs. Because let's be honest, good TA is hard to find. They're just hard to find. And if I can program an actually half-decent virtual TA, that's good. Let's go with that. It's just not worth it. I'm not saying we should get rid of TAs for educational purposes. I'm just saying TAs are going away as soon as possible because the robots will do a better job helping us do what we do. That's all I got. Thank you very much for coming. I'm sorry I went over 5 minutes. I really thought I was going to get through it.